The U.S. Missile Defense Agency and the Ground-Based Midcourse Defense Program Office will conduct Flight Test FTG-06A to demonstrate the ability of the Ballistic Missile Defense System to intercept an intermediate-range ballistic missile. This test will exercise missile defense assets spanning thousands of miles across the United States and the Pacific Ocean. FTG-06A will demonstrate the performance of the Ground-Based Midcourse Defense System, or GMD, which is currently deployed to defend the nation from long-range ballistic missile attack. FTG-06A will demonstrate the ability of the GMD system to intercept a threat representative ballistic missile target in space. FTG-06A is the culmination of many months of planning, ground test, and hardware preparation. At Vandenberg Air Force Base, California, a 3-stage booster vehicle was assembled, transported, and prepared for mating with the kill vehicle. The Exoatmospheric kill vehicle underwent initial assembly in Tucson, Arizona, and was integrated into the payload avionics module in Huntsville, Alabama. The payload was shipped to Vandenberg and mated to the booster and processed as the complete FTG-06A ground-based interceptor. After final processing and checkout, the completed ground-based interceptor was transported to the launch facility, emplaced in an operationally configured silo, and readied for launch. The FTG-06A flight test will begin at the Ronald Reagan Test Site, located on Kwajalein Atoll in the Marshall Islands. An intermediate-range ballistic missile target will launch from Mek Island in an easterly trajectory over the Pacific Ocean. The target selected for this test is carried aboard the Launch Vehicle 2 booster vehicle and will present a threat representative scenario for the GMD system. Soon after liftoff, a forward-based radar located at Wake Island will detect, acquire, and track the target. This ANTPY-2 X-band radar is controlled by the Command Control Battle Management and Communication System known as C2BMC. The radar will send tracking information to the GMD fire control system. This information will be used to create a weapon task plan for the interceptor missile launch. As the target continues downrange, the sea-based X-band radar, located in the Pacific Ocean southwest of Hawaii, will acquire the target. This advanced radar, situated aboard a mobile semi-submersible platform, will be responsible for tracking the target through the entire engagement. Target trajectory information from both radars will be relayed to the GMD Fire Control Node at the Missile Defense Integration and Operations Center on Schriever Air Force Base, Colorado. Data from the GMD Fire Control System will also be sent to the C2BMC system to provide situational awareness to combatant commanders across the globe.
Director, we have a launch detection.
Soldiers from the U.S. Army's 100th Missile Defense Brigade will use the GMD Fire Control System to manage the engagement. The GMD Fire Control System will calculate and deliver a firing solution and flight plan to the interceptor located at Vandenberg Air Force Base. Warfighters will exercise operationally realistic tactics, techniques, and procedures, and at the appropriate moment will order the ground-based interceptor to launch. At Vandenberg, the command launch equipment will provide trajectory flyout and intercept information to the ground-based interceptor. Upon receiving the data, the 3-stage interceptor will execute startup, internal power initiation, and launch.
3, 2, 1, ignition.
After the first two stages of burn, the third booster stage will adjust the trajectory to take the exoatmospheric kill vehicle to its separation point. Following separation from the third stage booster, the kill vehicle will receive trajectory updates derived from continued radar tracking by way of the in-flight interceptor communication system. The kill vehicle will position itself through a series of divert and control maneuvers to acquire the target with onboard sensors. The kill vehicle will perform warhead discrimination and maneuver to engage and intercept the target. At closing speeds in excess of 20,000 miles per hour, the kill vehicle will intercept the target warhead. The kill vehicle carries no explosives and uses only the body-to-body kinetic force of collision to destroy the threat warhead. Data collected during the test will be analyzed to validate and verify models and simulations used to evaluate system performance. FTG-06A will also serve as a data collection opportunity for new missile defense technologies. Ground-based mid-course defense is a critical element of the nation's overarching ballistic missile defense system. In the face of an increasing enemy ballistic missile threat, the ballistic missile defense system is deployed to protect the nation, our deployed forces, friends, and allies.